Yeah, good morning, ladies and gentlemen. We would like to welcome you here today. My name is Christina Rütten and I am part of the product marketing at Turk. My colleague Klaus and me would like to talk about cabinet condition monitoring. And in the next 20 minutes, we will explain how the condition of your switching cabinet affects machine availability. So, Klaus, we are online.
Oh, we are online. Sorry. Yeah, also a warm welcome from my side. My name is Klaus Ewinger, and I'm Director of Product Management for Interface Technology and also responsible for cabinet condition monitoring. Thank you for this introduction, Christina. So actually, how did we come across that topic, cabinet condition monitoring?
Yeah, about 5 years ago, we started with an idea, condition monitoring of control cabinets. With the first devices, the IM12 CCM for use in machine and plant construction and the IMX12 CCM for use in X areas, we offered a ready-to-fit solution. The CCM modules can be installed and even retrofitted in almost any control cabinet or any protection enclosure. The control cabinet guards offer 3 sensors which monitor the environmental parameters, temperature and humidity, and as well the distance to the control cabinet door. The IM12, IMX12 CCM were designed for limit monitoring. A teach-in process is used to put the device into learning mode, and it teaches itself to determine the limit values. The device sends a signal exactly when defined values are exceeded or fall below. The IM12 CCM features an internal data logger with timestamp and stores data for up to 2 years. This enables users to also detect creeping changes over long periods. Yeah, and then we very quickly recognized the potential of condition monitoring in control cabinets. With the IM18 CCM, the third model in Turk's cabinet guard series, we would like to tap this potential. Condition monitoring of control cabinets not only takes place on-site, the data can now be transferred to the IT world. The IM18 CCM provides a very flexible and cost-effective platform that allows you to implement a customized solution for your requirements.
Yeah, okay. So now we've learned the difference between condition monitoring and threshold monitoring. So when we're going into condition monitoring, what do we need for condition monitoring? For condition monitoring, we need data, a lot of data. But data alone is not enough. We need this data in context with time. So we also have to take the time into consideration. So why do we need that? We are recording trends. We are recording trends, and these recorded trends can be taken into comparison to patterns, known patterns. So what does it mean? If we're looking here at our cabinet, it could mean that over time, the temperature rises slowly. With a normal threshold, you don't see that slightly increasing. But a slight increase of temperature or humidity could be caused by a blocked filter of your air condition. So if you see this moving away, you can plan your maintenance of your air condition, take out the filter and put in a new filter and everything is fine. What is not happening when you are just looking on a threshold? Maybe the temperature is getting too warm, the lifetime of your devices are decreasing, and finally, maybe the devices go damaged. So this would we like to overcome, and that's the reason why we look on the trend and compare it with the pattern. Yeah, if we would like to put more benefit on this topic, we can take this recorded data into a cloud. So we are moving the data from one point locally to a cloud application. What is the benefit? Just moving the data from one point to the other. The real benefit out of it is that you have now full access on the data at any time, everywhere you are, and most important, system independent. So you can use your smartphone, you can use your tablet PC, or you can look in your workstation. You have the actual data available. And this helps you also to maintenance your devices in the cabinet. So finally, we have 3 or 4 sensors in the device, and we are recording this data, and when we transform this data into the cloud. So sensor to cloud. This is also one of our main campaigns in Turk. So how does our cabinet condition monitoring, Christina, fits to this campaign?
Yeah, correct. In addition to the 3 onboard sensors, temperature, humidity, and door distance, you can connect external sensors like a vibration sensor or a second temperature sensor to the IM18 CCM via Modbus RTU or CAN. These characteristic values can either be transferred to higher level systems or can be analyzed decentral on the device, on the CCM, according to defined patterns. This is done by customized apps that can be installed on the Open Linux platform of the compact device. In this way, measured values can be pre-processed and prepared on the device for specific requirements. Big data is filtered to smart data via decentralized pre-processing. Cabinet guards works effectively, especially when data is available at the right location. In higher level systems, this can lead to analysis in cloud applications. For example, to calculate the life cycle reduction factor or to define maintenance time. The IM18 CCM provides the necessary data traffic via its Ethernet interface. Bidirectional communication enables users to analyze data material from the factory level directly to the end devices, everywhere and at any time.
Yeah, that's a good point, Christina. So big data to smart data. Okay, let's summarize the benefits out of it. So first point, it's really easy to install. Just put it on a DIN rail, connect it with a power supply. That's it. So it's perfectly designed for retrofit.
Yeah, and the CCM modules can flexibly adapted to existing condition monitoring systems. The Linux operating system enables the installation of customer-specific applications, such as specific operating front ends or connections to cloud systems.
If you have already installed devices with a CAN bus or a Modbus in your cabinet, like energy meters or frequency converters or vibration sensors, you can easily connect also these signals to our CCM, and the CCM will put this information together with the 3 sensors into, for instance, a cloud application.
Yeah, and customized programs can be integrated to allow intelligent pre-processing of data, and this reduces data streams to higher level systems.
Yeah. Okay, I think the most important goal of this cabinet condition monitoring is really reducing unplanned machine downtimes and thus increase machine availability.
Yeah, and Klaus, why is it so important to monitor a control cabinet?
Yeah, if you look at a control cabinet, it's a piece of metal and maybe a little bit of glass. It's not so really important. The important thing is inside. These devices are really the most important thing. If there's a failure inside of the cabinet, this could lead to an unplanned machine downtime. And this is the problem. So these devices are not really designed to withstand higher temperature or temperature changes, humidity, stresses, mechanical stresses. So, and that's the reason why you should monitor the condition inside of your cabinet to protect your devices internally. So I would always say maintain before it's destroyed.
Yeah, and decentralized automation is also advancing more and more.
Yeah, decentralized automation is really a really important topic. In former times when I was young, we had large cabinet rooms. So really big rooms, they are secured, they are conditioned, everything was fine. Nowadays, these cabinets are moving outside, closer to the machines, closer to the real application. And what does it mean? It means that all the stresses, which is really located in front of the machine, also stresses now the cabinet. So higher temperature, more humidity, more vibration. So think about of a food application where cleaning goes on. If the cabinet door is open during a cleaning process, everything will be destroyed, and this leads immediately to a plant shutdown. So decentralized automation, I think, is one of the most important topics to install a cabinet condition monitor in your cabinets if they are installed outside.
Yeah, and if control cabinets are installed in a distributed manner, protection against unauthorized opening is also much more complex.
Yeah, it's also another good point. So we have in Europe or Germany a law where companies who are supplying energy or water are forced to monitor the cabinets where critical infrastructure is installed, like PLCs or computers, because sometimes unauthorized people are opening the door and trying to change something on these devices. And what does it mean finally? Maybe an energy supply stops or water supply stops. No one wants to do that. So they are forced to monitor the condition or the door opening of the cabinets. They also have to document that. So also a really important point.
Yeah, cabinet in the cloud sounds like a great idea. Can we show something?
Yeah, of course, Christina. Now I have the cabinet in my hand. So here on the tablet PC, which is directly connected to the cloud application. So I can see every data which is necessary to monitor my cabinet and to detect if there is a maintenance necessary. What I can see here on this screen, so I can see, of course, an absolute value of the temperature, but this is not real the benefit. I can see the trend of the temperature, so I can see if there's a slight increase of temperature and if I have maybe to maintain the filter element of my air condition. Also, if I have multiple cabinets spread it out in a country, I have a map available. So I can see also the location of my cabinets. I press on it and I can see all the conditions of my cabinets inside. And also, of course, I can look at historical data. So if I see maybe 2 weeks ago or 3 weeks ago, some additional data for temperature or humidity, which is sometimes quite important to see how was the history. So everything is now stored in the cloud and I have full access on this data, whether I use a tablet PC or my smartphone, or I'm using a workstation locally. I think this is one of the most important things. And if I want to have an immediate alarm if someone is open the door, yeah, of course it goes. So I just open the door. Okay, locally the LED goes red, but I also see it here on the cloud application that someone might be opening it unauthorized the cabinet door. And close again. Well, Christina, that's good. Let's summarize everything together.
Yeah, the primary goal of cabinet condition monitoring is to reduce unplanned system downtimes and thus increase availability.
The primary goal, as we said already, is really to reduce unplanned machine downtimes, and the cabinet plays really a central role in all of that. So we have intelligent sensors, we have intelligent systems on the other end. So the cabinet is in between. But if something goes wrong in the cabinet, then the complete system will fail as well. So it's really important also to monitor what's going on in your cabinet. If it's the temperature, if it's the humidity, if someone's opened the door. Yeah, so we hope we've been able to bring you this topic a little bit closer to you, and you get now a better understanding of what's going on in your cabinet, and we are looking forward to go in further discussions with you. Thank you and goodbye.
Yeah, thank you.